Good morning, everybody. My name is Ramiro Cardenas, and I am going to present to you guys an article that I found on Entomology Today, which was one of the uh, websites that Dr. Wenger provided us when he gave us the handout. And the article is called No Buzz, No Problem. The study shows how honeybees pollinate blueberries. And I became interested on looking at this theme because I'm currently working with berries in Watsonville, and I wasn't aware that you need some kind of insect to pollinate the blueberry plants. And here, do you guys know that if blueberries need to be pollinated by any kind of insect, or not sure? No? Well, the study shows that yes, they need to be held by some kind of insect, and it goes over the study what they did, and as you guys can see here, that the bee is almost the same size as the blueberry flower, and it kind of brought my attention of how the blueberries get pollinated. In the study, it shows that 700 million pounds of blueberries are sold every year in the U.S. So it is very important economically and ecologically. Blueberry growers bigger than 5 acres rent honeybee hives for pollination. Before they didn't know if bees really help pollination, but in the study it showed that they do. The article talks about the mechanisms of how honeybee pollinates the flower. I want you guys to pay attention to this part of the bee and the flower. This is how the bee pollinates the flower. And it's important to know a little bit about the anatomy of the insect and the flower, and because the bee carries all these tetrads, which are the pollen grains, throughout the body. But in some sections of the bee, they have more tetrads. So the interaction between the anatomy of the bee and the flower anatomy, we're going to see a little bit of this is a perfect flower, but there's some kind of restriction here in the corolla of the flower, which the corolla is all the petals together. So the bee can only enter its head here. It doesn't like go inside the flower to kind of shape the pollen grains into the stigma. The stigma is where the tetrads lay, and it gets the germinating tube, and it pollinates the ovules. So it's a bell shape, and it limits the access for the anther for the bee to enter the flower. So the honeybee does not perform buzz. Buzz is when the insect moves its wings really hard, so you can shake the flower, so the anthers will release pollen to the stigma. And the study showed that they found that only 6% of the pollen was in the body of the bee, 12% on the head, 19% on the foreleg and the middle leg, and 63% on the hind leg. This is the pollen basket, the pollen comb, and the Basitarsus, which is, I'm going to explain in the next slide. So 63% of the pollen was found on the hind leg. This is the front leg, right? The leg was modified to have an antenna cleaner, it helps in some kind of the open flowers. When the bee cleans its antenna, it will shake some of the pollen for it to get pollinated. But in the case of blueberries, flower is like enclosed. The anthers are enclosed in the corolla, so it is important when the bee reaches the flower, it puts its Basitarsus close to another flower in the cluster. So the Basitarsus has about, this part has about 200 tetrads per Basitarsus, and these are the tetrads here. You only need 125 tetrads to pollinate one blueberry flower. So they found that the most important part of the bee in pollinating blueberries is the leg. So during the observations and the findings, the bee first lays in the flower cluster and sometimes it gets inside the corolla, but most of the time it's just she sits there and grabs its antennas, but the study shows that these four parts, what they do, these four mechanisms. So it grabs an adjacent flower that can pollinate the flower. The leg stretches across and brushes the stigma. So that's one more way to pollinate the blueberries. And the leg the most important one is number 4. Is where the leg enters the corolla and deep enough that the tarsi can contact the anthers, and that way it carries the pollen in the Basitarsi, and it is more probability for the leg to pollinate the stigma. So before the study, they were seeing only 100 tetrads per insect, and after the study, they counted about 1,133 non-cubicula. The cubicula is, sorry, I didn't explain before, but it's where the bee carries the pollen to the beehive. That it wasn't included on the study because it has a lot of tetrads, thousands, I think. And they only counted the tetrads in the body where they thought it could help pollination of the blueberries. So the tarsi has more probability to contact the stigma. The bee holds itself with another flower. So the bee, when it lands in the blueberry flower, it holds itself with another flower. That's the most important pollination for the bee.
Oh, yeah.
So honeybees have a restriction to enter the flower, but however they do help pollination. There's some other bees, not the honeybees, that help pollination, which are the bumblebees, which really move their wings really hard so they can kind of shake the flower. And bumblebees, carpenter bees, and andrade and haïcid bees. I'm not familiar with those. But, do you guys have any questions about them? Thank you.
All right, thank you. Interesting. So that does bring up another interesting point. So if I understand correctly, basically, right, the bees are sort of functionally grabbing onto other flowers and inserting their hind legs into the neighboring flowers and pumping them around to collect the pollen, and that's the major mechanism of pollination?
Yes.
Awesome. So that's actually, I haven't heard that behavior before, so that's interesting. But I know that, a lot of flowers aren't particularly well suited to pollination by honeybees. They have evolved with other hymenoPtera in the area to be pollinated, so you'll see that certain crops are better pollinated by certain bees. But there's been some interesting research I've seen where they've demonstrated that having a mixture of different species of bees in your crop actually increases pollination efficiency as well as yield. In blueberries specifically, they did a study where they had some fields where they had just honeybees, some fields where they had honeybees and bumblebees, and some they had honeybees, bumblebees, and one of those other bees you mentioned, like the hive bee or something like that. And they showed that as you increase the number of pollinators, that they had more berries per bush. The berries on each bush tended to be larger, and they had higher seed set, which is usually a sign of better pollinator efficiency. So generally, and there's similar research in almonds showing that if you mix orchid bees and honeybees, that you get higher pollination efficiency with multiple species of bees. So it's not unusual.
Do beekeepers offer services of actually providing multiple species at a time, or are they just dedicated to one species?
Not usually. Most beekeepers are just going to be working with honeybees. I'm sure there are beekeepers out there who have other bees. The trick is, sometimes you're working with, let's see, what am I? I'm on the subspecies, so I don't have the pictures here. Do you remember those alfalfa leaf cutter bees we talked about on Tuesday? The ones that cut the leaf discs and put them in the little drill holes? Those guys, in order to rear them, they need to have a cold period to overwinter during, or else the eggs will never hatch. They basically have like a cold-triggered hatching mechanism. And so what beekeepers will often do is they'll take these big blocks full of eggs after the alfalfa season and they'll put them in a freezer for a substantial amount of time. And so you get to this point where the amount of infrastructure you need to maintain some of these wild bee populations is pretty high, or you need to be willing to ship all those bees like up to Canada. So in Canada, like all the alfalfa growers up there and a lot of the people who have custody pollinating, they have tons of alfalfa leaf cutter bees available to them because you just leave them outside all winter. But here in California, you actually either have to import them or you need to have a cold house where you store them. And that's actually becoming a bigger thing. At the CBBA meeting, right, they were talking about putting bees in the freezers. That seems to be a mechanism that people are using now just to keep their honeybees healthy over the winter time. But
is there any programs, like breeding programs, to create like a crazy hybrid of bees and
let's get to that in just a second. We're going to talk a little bit about hybrid bees today. So let's jump into this. We didn't quite wrap up our last talk, which was about what makes honeybees. You remember we were going through that great big list of all the classification of honeybees, and now we're down at the very smallest level, and that is subspecies of Apis mellifera. So Apis mellifera, right, is our Western or our European honeybee, and these guys actually aren't from Europe. They originated, let's see here. It is believed that they basically first emerged in sort of sub-Saharan Eastern Africa, and then they spread up into the Middle East, and then up into Europe, so that, you know, we have a lot of diversity in this species. As the species spread into these different regions, they encountered different flowers, they encountered different climatic conditions, and we saw, you know, a pretty considerable amount of adaptation to these regions. If you just think about the climates of these regions, we have honeybees up in Northern Europe, where we have a classic temperate environment, very cold winters, highly seasonal flowers. We've got bees in the Mediterranean area, sort of where they're dealing with climates like we have here, warm, wet winters, with bloom periods after that, followed by substantial periods without anything to feed on. And then we have bees down in sub-Saharan Africa, where it's tropical, and there are resources most all year, but there is a wet season which is not optimal for bees. So even though this is all one species, we see a pretty good amount of variation in behavior, in morphology, in flower preferences, and that's something that people have taken advantage of for a while when rearing their bees for their particular crops or their particular landscapes. Consequently, people consider these different adapted populations to be subspecies of the honeybee, or races. Race is kind of an out-of-date term. Subspecies is what most people are calling it now. But if you're talking to beekeepers, you'll hear the term subspecies, you'll hear the term race, you'll hear all sorts of stuff like that. And as I mentioned, these bees are going to differ in their size, in their flower preference, patterns of their hairs, colors, wing veins, all of that. But the important thing to keep in mind here is that these are much more like breeds of cow or varieties of crops than they are different species from one another. You can hybridize these bees. There's actually speculation that here in the United States we've imported a variety of different races or subspecies of honeybees, and there's speculation now that all of those races are so interbred with one another due to just having a limited population brought in, that American honeybees are now an American subspecies, which is distinct from all of these because they're kind of a, the mutt that you pick up a pound of honeybees. So anyway, as with all things taxonomical, where you're trying to figure out how many of any given division there is a disagreement. Currently, people seem to believe that there's anywhere between 28 and 44 subspecies of bees, but really you can divide those into three major regions. We have European honeybees, Asian honeybees, and then African honeybees. Actually, that's not entirely accurate. If I were to draw that line, let me correct that. African honeybees, in general, only include bees below the Saharan desert. European honeybees include European honeybees and those in North Africa. And then Middle East and everything that sort of goes east of that is considered Middle Eastern or Asian. Regardless, we're not going to go through all the subspecies. That would be a lot of work. What I'm going to cover are the 4 subspecies that you most commonly find here in the United States. Forgot about that.
You can just press the back button on top of the video.
Thank you. I'm going to be tapping the back button a lot. That's not doing it. Okay.
I think if you delete annotations, there was a way to do it.
That was the wrong thing to do. Let's undo that. There we go. Okay.
Try that thing like on the right. No.
Nope, on the right.
Yeah. So
Yep.
like okay,
Here.
the column that's like outside the main column. Try that bottom thing. Or no, wait.
This
no,
bottom thing?
Never mind. Actually, no, I don't even know.
Yeah.
Oh yeah.
Yes. That's what I want to do. Cool. Thank you for bearing with me. I think this is the first moment that I have felt truly elderly. Right there, that was it. I just encountered technology and floundered helplessly in front of a group of younger people. Cheers to my youth. All right. So, intentionally, there have been 5 subspecies of honeybee introduced to the United States. 4 of them were European varieties, and then there are those African honeybees that we've heard so much about, right? Africanized bees. So we're going to go through the 4 major races that we see here in the United States, and then we'll touch on Africanized bees. So the first honeybees that were brought over were Apis mellifera. So just to give you the idea of how subspecies naming conventions go, you have your genus, right? Apis, and then mellifera, so that's our species name. And then if you're talking about a subspecies, you just tack on another name right after it. So Apis mellifera is the German honeybee, or the black bee. These guys were brought to the United States back in like the 17 and 1600s. They were the bees that are most associated with Northern Europe, where most of the migrants were coming from, so of course they brought their honeybees with them. These guys, though, are not particularly common today. You don't see Apis mellifera much in the United States because they are highly volatile, highly defensive. If you open up the hive, there are reports that these bees will boil out of the hive, so they'll just kind of come rushing up at you. Very, very defensive. And that's not super ideal if you're trying to do a commercial operation. If you've got a couple bees in your backyard, it's not a big deal. But if you're trying to rear 1,000 boxes of bees that are going to come at you every time you open the box, that's going to get very tiresome. Also, these bees are highly susceptible to a disease called European foul brood, which is a bacterial disease. We'll be more detailed on all the diseases when we get to bee pests and IPM, but suffice it to say that this was a disease that swept through a lot of Europe and the United States, and it more or less wiped out this bee variety here. Yeah, and as I mentioned before, they're aggressive and hard to handle. So, there we go. Uh-oh, wrong one. Oh no, oh no, it's only getting worse. There we go. All right, other major subspecies we have is Apis mellifera caucasia, or the Caucasian bee. These guys are from Eastern Europe, sort of the Caucasus region around the Black Sea, and they are characterized by being very gentle. So these were brought into the United States as sort of a substitute for these highly aggressive Northern European honeybees. As you can see, it's another black bee, so their coloration is primarily dark. They have a little bit more of those light-colored hairs on their bodies. And people like them because when you open up the hive, they didn't really care. They just kind of chilled out and let you do your management. The issue with these honeybees is that they tended to use propolis very extensively. If you've got Caucasian honeybees and you have any sort of minute crack, they're going to paste it shut with propolis. So if you're trying to get your frames out, you're going to have to get into the hive tool and crack them off. You're going to have to break all that propolis. Right here in this picture, so what's going on in this picture is this right here is the entrance to the beehive, and you see all this yellow junk in there? That's all propolis. Basically, these Caucasian honeybees have come in and they glued the entrance shut, so that the only entrances are these tiny little squares right here. They basically created a handful of bee-sized entrances. And that's not a huge problem, but it is going to make air regulation a little tricky. So bees, when the hive is too warm or too cold, will fan their wings in order to move air around. And if the entrance is restricted, they might not get a lot of good airflow. And also, if you're planning on putting new bees in this hive, you might want to clean your hives out, and now you have to go in there and like bang, 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 knock all that propolis off. So that's not super ideal. These guys also tend to be hive robbers. So what that basically means is these guys, when they're out buzzing around, you know, looking for flowers, if they come across another beehive, they're just going to pop on inside, grab a little bit of honey, and they're going to go back to their hive and drop it off there.
Can you tell when like your hive's been robbed or being robbed?
I know you can. A lot of beekeepers talk about hive robbing behavior, and they're aware of when they're being robbed. I think in general, what you'll see is you'll have, like, say, 3 hives sitting in a row, and let's say 2 of your hives are very strong and one of them's kind of weak. You notice your weak hive is getting weaker and weaker and weaker, and you're seeing a lot of travel in between the 2 strong hives and the weak hive. I think that's usually a sign that you're being robbed. That's one I'll have to look into, because I'm kind of curious.
Don't hives have like bouncer bees? That'll take the...
They do, but if you have a weaker hive that's not as good at defending off a large number of robbers, you know, the bouncer bees might not be able to fend off.
So they come as like a team?
I'll have to look into that. I'm not going to say anything that potentially is going to be me having to come back here later when we're talking about beekeeping and be like, okay. Or more accurately, when we go and meet with the actual beekeepers, and when you say something like, so Dr. Wenger was telling us about these robber, teams. You're going to be like, what the hell are you talking about? So I'm going to stop and not talk out of my butt like I usually do. All right. And I'm the only one who gets to say it. No, I usually don't talk. I'm going to stop. Anyway. Point being that there is believed to be no pure stock of Caucasian bees in the United States anymore. They've been, again, so highly mixed with all the other bees that we have that there's probably some amount of Caucasian genetics left, but it's largely been bred out. Nobody's keeping these bees exclusively. All right, now we're going to get to the two species of bees that subspecies that actually are common. There's the Carniolean bee and the Italian honeybee. So the Carniolean, Apis mellifera carnica, these guys are from the southern Alps of Austria as well as the Slovenian region. These guys are the second most popular bees, and we're starting to get into bees that look a little bit more like what we're used to seeing, right? We've got some obvious banding on the hind end. It's a little bit more of a golden colored bee. And these guys have a lot of features that make them very appealing to American beekeepers. First, they're extremely hygienic. What does that mean? Basically, it means that when these guys are roaming around in the beehive, taking care of things, if they find a mite, if they find a beetle larva, if they find a dead brood, they basically pop it out and they throw it away. And they sanitize the region and they repurpose it. So they're very good at making sure that sick members of the brood, that pests and things like that get tossed out of the hive. So these are very appealing to growers now that are dealing with varroa mite issues and things like that. They also are very gentle. They're difficult to get upset. They have low overwintering numbers and build quickly in the spring. So what does that mean? Basically, over the winter, right, bees are living off of their honey reserves. So if you've got a beehive that's got a ton of workers overwintering, you're going to go through your honey and your pollen supply very quickly. You're going to have more likely the case that your hive dies off. But with these bees, they keep very low numbers of workers so that a smaller reserve will last them longer. And in the springtime, when the nectar starts coming, they invest a lot of energy into building up the brood so that you get a ton of workers very quickly as soon as the flowers pop up. And also, these guys have a tendency to forage over long distances. So you plop a hive down, you don't have to move it as much because they're likely to travel long distances from the hive to find nectar resources.
So because they, they lower their population when they're overwintering, is there like any way to actually decrease the amount of drones that are being produced? That way, when spring comes around, you have more actual worker bees than you do drones.
So typically the drones will be thrown out in the late fall, early winter, because they don't want to keep the drones around in the wintertime, for the exact reason you're pointing to, that they're kind of a waste of space. And typically drones will start getting produced in bigger numbers when there's nectar flow and reason to think that the hive may split apart and reproduce. So I don't think that's a huge problem during the winter time. There are some significant negatives, though, with this particular subspecies. The first of which is they have a tendency to swarm. Because they can maintain their population with a small number of workers, the hive doesn't have to grow very big before the hive basically says to itself, oh, let's clear out and form a new hive. So they'll swarm, split in half, and leave. And they also don't do particularly well in hot weather. So they're not particularly great bees for, say, beekeeping in the American Southeast, here in the Central Valley. Not the best choice. And then finally, we have the most common, by far, this is the most common bees we have in the United States, Apis mellifera ligustica, or the Italian bees. So these are bees that originated in southern Italy, and they were imported largely by Langstroth, the guy who invented the Langstroth hive. He also popularized these bees. He was a big proponent. They are also sometimes called the three-stripe or the five-stripe Italian bees, because if you look at them, they've got nice and clear 1, 2, 3, 4, 5 stripes on their abdomen. In some of them, these first two stripes will kind of be hidden, and you'll sort of have 1, 2, 3 right across the back. But either way, they're a golden bee with clear black stripes. Kind of sets them apart from the other varieties we talked about, which are primarily black in color. And people like them for any number of reasons. They're reasonably gentle, so you can open up the hive and manipulate it easily. They're well suited to all of the climate regions in the United States. I mean, they're from southern Italy, so they do well in the heat, which is nice. They tend not to swarm, and they don't use very much propolis. So it's put them in a box. They stay in the box. They don't muck it up with their, glue spit. That's nice.
Alright, quick question about the climate. Like I heard, say if it's like 100 degrees outside, it's like way, way hotter inside the beehive. Like how much hotter is it?
See, and I've heard the opposite. That bees are pretty good at lowering the temperatures. So oftentimes when bees have sort of an optimal range they want to operate within, and so the bees will sort of set up fanning behavior to pull air in from the outside and push it out of the hive. But I don't know that optimal temperature, and again, the not talking out my butt thing, so I'll get back to you on that. One major disadvantage with this particular subspecies is they tend to overbrood, which basically just means that they invest too much in worker population during the slow seasons, and they tend to put too much brood into the combs. Consequently, they eat through their supplies pretty quickly, and you're going to have to feed them. So you have to supply them with sugar water and pollen cakes during the off-season, or else it's very likely that they will die. And when we were at the CBBA meeting, I thought that was interesting. That's something I was pretty consistently hearing from beekeepers, is people speculating, when is the right time to start putting pollen cakes in my hives? Should I be putting pollen cakes in my hives over the winter? Should I be putting pollen cakes in my hives as early as August? You know, when is the right time to actually start feeding my bees so that I don't see die-offs in the winter?
Is there a certain kind of sugar you have to use, or just any kind of grocery store sugar?
Some people say that you can feed honeybees just sort of a straight-up sucrose solution, so water with sugar. I mean, that's going to give them the carbs, and I mean, that's the main purpose of the nectar, is an energy source. But I think you are going to be shortchanging them on nutrition. So there are companies like Daydamp that sell proprietary mixtures that are going to be a little more nutritious. And a lot of the times, if you're going to go with the sugar solution, you've got to make sure that your pollen cakes are very inclusive of proteins, fats, amino acids, and things like that, so you get an entire nutrition perspective. But yeah, beyond that, I think you want to go a little more complex than just straight up sugar. So let's go to the complete breakdown. Get rid of my stripes. So, just a review, right? Kingdom Animalia. Phylum is the arthropods. Hexapods are the class. Order Hymenoptera. That's all the stuff we covered in economic entomology. Well, actually, we did that. Suborder Apocrita, which would be, basically anything that's not a horntail or a sawfly. Infraorder Aculeates. That would be the bees, and wasps, and ants. Superfamily Apoidea, the bees. Family Apidae, genus Apis, species Mellifera. And then, as long as you're here in the United States, chances are you're either going to be dealing with subspecies Linguistica or Carnica. So that's our big old breakdown of bee diversity here in the United States. That being said, so we had a question earlier about hybrids, right? So as best I can tell, there's not much effort to hybridize different species of bees. By definition, because they are different species, you can't really crossbreed them and expect to get good results. But back in the 1800s, early 1900s, companies like Daydamp did put forth efforts to create hybrid subspecies mixes. So they would keep independent hives of different subspecies, and then they would mix the drones of one subspecies with the queen of another subspecies. And that way, you would get these offspring that are hybrids of subspecies. And those offspring would have hybrid vigor, and they would generally perform pretty well. But that's really fallen off. I don't think they sell hybrids of any sort anymore. And I'm guessing it's because the hybrids didn't perform all that much better than the regular subspecies did by themselves. I had a little trouble figuring out why they don't do it. It probably was also just a whole lot of work. Breeding and rearing of queens is a whole profession in and of itself that we'll talk about later. All right. So just to very briefly touch on these, I mentioned the fact that there were Asian and African subspecies of Apis mellifera. In general, these are just much more poorly studied than the European varieties because a lot of bee science has been performed here in the United States as well as in Europe, so they focus mostly on the varieties they have. There's been research in East Asia, but they're mostly focusing on the honeybee varieties they have, which are entirely different species. So not a whole lot known. In North Africa, the bee varieties tend to swarm frequently. They're not particularly well suited to beekeeping, so people haven't looked at them much. In sub-Saharan Africa, there are two major races, and they've been studied a bit because there has been some management. The most notable of them is Apis mellifera scutellata. Whoops, I forget it. Scutellata. These guys are highly migratory, highly defensive. They're basically known for setting up a hive, building it up just far enough, and then packing their bags and leaving. They tend to scare very easily, so if you mess with their hive, they're going to pack up and leave, and they leave behind a lot of resources. So typically, people were managing them in a destructive harvest sort of situation, where they'd scare the bees off, they'd destroy the hive, and collect the honey. And then there's Apis mellifera addisoni, which is similar but not as easily cultivated, so people haven't messed with it. So this brings us to Africanized honeybees here in the United States and North and South America in general. So everybody's heard of Africanized bees, also known as killer bees. Yeah. Killer bee is not the preferred term, that's kind of a media hype name, but so we'll stick with Africanized. But basically what happened was there was this beekeeper, Warwick Esteban Kerr. He's a bee breeder down in Brazil, and he wanted to create a hybrid bee between subspecies that would be particularly well suited to pollination in South America. The climate in South America is much more similar to sub-Saharan Africa than it is to Europe, so he reasoned that sub-Saharan bees would do better than European bees. And so what he did was he imported a whole bunch of those Apis mellifera scutellata into Sao Paulo, Brazil. And then he basically carried out a whole bunch of experiments where he crossbred a variety of European subspecies with these scutellata subspecies. Specifically, he also brought in Iberian honeybees, which would be honeybees from the Iberian Peninsula, Spain and Portugal. Unfortunately, what happened, as with many of these sorts of things, is that they escaped. What happened in 1957, they had a visiting beekeeper. I don't know if this is true or if this is Warwick pushing the blame on somebody else. But the story is that in 1957, they had a visiting beekeeper, and the visiting beekeeper noticed the hives weren't doing as well as he thought they should be, so he removed something called a queen excluder. So what a queen excluder is it's basically a metal or a plastic mesh that you can put on top of your bottom box of the hive, and the mesh is such that it's just large enough for a worker to pass through, but a queen is too big to get out of it. So you pop one of those on the top of the hive, and you make sure your entrance hole is so small that the honeybee queen can't get out, and the queen is stuck in the box. That way, your reproductive can never escape, and you can keep the bees contained. Of course, he takes the excluder off, and before they discover that the excluders are off and they need to fix that, Apis scutellata, as I mentioned before, likes to swarm. They swarm 26 times. So they send out 26 new colonies into the surrounding landscape. So these Apis scutellata spread very quickly. By sort of the end of the century, by the 2000s, they were all the way up into North America. They had managed to hitchhike their way over into basically all of South America. I want to say the only country in South America that does not have these is Chile, and that's just because Chile has the Andean mountains basically cutting off one entire side of the country. So Chile is very lucky. No Africanized honeybees, no great Phylloxera. Good for them. But anyway, so this is problematic because, as I mentioned on the last slide, scutellata has two major traits that are irritating. They are super defensive of their hives, and they have a really strong tendency to swarm. So, if you approach a Scutelata hive, it's very likely that they will attack you, and they will spread very quickly through swarming. So they're going to get out there and spread all over the place. And these Africanized honeybees have been linked to basically mass stinging events on more than 1,000 people. There are some news stories that get a lot of play in the United States. There was an orchard worker, I want to say in southern Colorado, who got attacked by a swarm that had settled in his orchard. He's an old dude, and so they have pictures of him in the hospital, like just completely covered in stings. And yeah, it's not a good look. But anyway, this is just showing the spread pattern. You can see Sao Paulo right here. So they escaped in sort of 1957. By 1970, they're basically over the entirety of Brazil.
Did he get in trouble or anything?
I don't think so. He didn't remove the bee. I don't know if the other beekeeper did, but I can't find that other beekeeper's name, so I'm guessing that they just sort of all said, oh, some beekeeper. Private buddy, they didn't want to get him in trouble. Either way, you can see by the 90s it was all the way up into the United States. There was actually a program where they were trying to stop it from getting across the Panama Canal, and what they were doing was they put a whole ton of European honeybee hives right there, and the idea was that that would be sort of a reproductive barrier. Swarms would come across, and they would mate with these European honeybees, and they would sort of like bleed out all the Africanized genetics and replace it with the European genetics. Unfortunately, that didn't work. Oh yeah, and here's the American distribution of these guys. It's a pretty useless sort of map, but point being, this map says there's none in Fresno, which is absolute nonsense. I can't believe that they have them in Madera County and the bee somehow just flew right over Fresno. Yeah, I'm going to give Fresno a miss. Or maybe they did. Oh, them are, all the SoCal bees are talking smack about the Central Valley bees. Anyway. So, there's a couple of issues here with these Africanized bees. One is the obvious one. We got these mass stinging events. That's what gets the most play. There's any number of stories of people and livestock and pets dying in mass stinging events. There are stories that these bees will actively attack people who are as much as a kilometer away from their hives. So that's sort of the level of aggressiveness. Those are weird one-off events, but I mean they happen. There's a real lack of competitiveness in the European honeybee genetic material. So basically, when these bees hybridize, it seems like the bees that do the very best are the ones that have a lot of African genetic stock. So over selective periods, the bees that have a lot of European genes tend to die out. The bees that have a lot of African genetic variety survive. And so when you look at hybrid colonies, generally 85% of the genetic material is linked to African origin.
Will the African aspect ever die out or phase out the genetics?
I think what could happen, and this will take a while, is probably through selective breeding. You could not necessarily get rid of the African genes, but you could select for Africanized varieties that are gentler. That's what's happened with a lot of the European honeybees. Keep in mind that a lot of these European honeybee varieties were probably similar to this originally, but they've been cultivated for basically a couple thousand years. And so there have been beekeepers that have been constantly selecting for the hives that tend to stay where they're supposed to be. They select for the hives that are gentle. And so we've slowly selected towards the traits we like. The problem is these bees aren't that right now. So there's probably going to be, over time, as long as people are cultivating these hybrid bees, movement towards those traits we like better.
So wait, say if you have one type of a bee, right, and then you bring a bee from another subspecies or whatever, and you put it into that hive, will it take or no?
So if I had a pack of Italian honeybees, and I had a pack of African honeybees, and I took a couple of, slots of brood from my African hive and plump, 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 stuck them in my Italian hive.
Or just a queen.
Or a queen. That's a good question. I don't know. You have lots of questions I don't know the answers to today. You can requeen hives. So if you have a hive that's weak and you want to requeen it, you can purchase a queen in a little cage. It's kind of cool. The queen comes in a little cage, and they have the hole that lets her out of the cage is plugged with a piece of sugar candy. You pop that inside the hive, and the queen will basically eat the candy. The workers will eat the candy. And the idea is that in the amount of time it takes them to eat through that candy and let the queen get out, the workers are acclimated to her, and they are willing to accept her as the queen. If I were just to grab the queen and be like, in you go, chances are the workers, they have those bouncer bees we talked about earlier, they're going to sit there and they're like, who are you? Who do you think you are coming into this hive, laying eggs? We got a queen, we're doing just fine. So normally what you got to do is you got to put the new queen in, you got to find the old queen, and, and then they'll eventually take the new queen. All right. Good Lord, let's hope that's not me talking out my butt again. We're going to find out. Cool. And then finally, there's an issue with, it's just difficult to manage these hybrid bee varieties with techniques that are designed for European bees. High swarming, high defensiveness. Oops, that's supposed to be safe. You can't rear these near homes in urban areas because they are so aggressive. So these are some issues. There's concern that there's enough of these swarms flying around that even what are classically Italian or Carnican stocks are going to eventually start introgressing with the African genetic stock. And there are some people who believe that if you're beekeeping in the southern United States, that nobody has straight-up European gene stock anymore. It probably all has a certain amount of African genes introgressed in it.
Is there a difference in the quantity of honey that African bees make compared to European bees?
Well, that is the funny thing, is these African bees are really good at pollinating and making honey down in South America. In any area where they're kept near European honeybees, they tend to outproduce European honeybee hives. And so they are actually really good bees. Congrats on Warwick, he created a bee that's really good at pollinating in South America. So I think there's potential room for selective breeding programs and things like that to help create a bee that's a little easier to manage, but still, does a good job of pollinating. All right. And this is my last little point. There's been some speculation. People basically are looking at these European varieties and these African varieties. They basically are saying, why is it that all of these African subspecies we have tend to be more aggressive, more prone to swarming than the European varieties? And there's been some speculation as to this. One speculation is that Africa has a lot more beehive predators. So that's going to naturally select for bees that are very aggressive and are more likely to attack things that are messing around their hives. Think of like the honey badger, right? Honey badger literally tears open beehives and steals the honey, in addition to attacking things like wildebeest and the like. Just creatures that are kind of fundamentally known for being badasses. Tropical Africa also tends to have year-round resources. So you've got honey, you've got nectar available basically all year round in the tropics. So it's not a big deal for bees to abandon their hive and to move on to something else because it's pretty easy to set up a new hive somewhere with resources. If European honeybees abandon their hives very frequently, they may abandon their hive and scoot off at the end of summer, and they're not going to have floral resources until the next spring, in which case they'd be out of luck. So for European honeybees, it's favored to stay put. You don't want to pick up and scoot off somewhere in the middle of a bad season. Oh, guess that's it. But yeah, so those are the two big things. The book has a nice long list of reasons. I thought these two seem to be the most likely explanations for some of this behavior that we see. All right, and we will talk about Africanized bees later in the semester in a little bit more detail. So, let's jump into lecture 3, which is insect sociality.
I don't think you posted it.
I didn't.
Oh, okay.
Of course. Let me... Yep. Okay, course documents, lecture files. Okay, that's going to take a minute, but it'll pop up here. All right. So, we spend a lot of time talking about honeybees being a social insect, so that does bring up a point of what is sociality. What do we mean when we say that a particular organism is social? And basically, sociality, or a social organism, is any group of individuals of the same species who are organized in a cooperative manner. So basically, sort of the law of the land in biology is natural selection and evolution, right? The idea that whatever helps you reproduce the best is going to be the thing that is going to get passed on to the next generation. That's universal. And for a lot of species, they found that behaving cooperatively, working with other members of the same species, is what helps them survive the best, is what helps them reproduce the best. And so those cooperative traits are what get passed on. And oftentimes these are sort of, there's any number of reasons. There's rearing offspring, collecting food, building shelters, protection from predation. In mammals, we see cooperative behavior associated with hunting and gathering food. Basically, sociality is just sort of not tremendously common if we're going to consider it, but it's not uncommon either. There are a large number of social species we see. There's a certain amount of society found in vertebrates, and there's a certain amount found in invertebrates. And what we find is that sociality in vertebrates versus invertebrates is very different. Very different sort of mechanisms of cooperation. In vertebrate societies, we find that social behavior can be very complex, very different between different species, but in general, it's driven by selfishness. Basically, conforming to social behavior is all based on the desire to reproduce better, and can take any number of roles which are associated with dominance hierarchies. So, basically, we see oftentimes parental care is required in vertebrate society in order to socialize young. They need to be taught how to be social. So we see that not just in people, where, basically it takes you like at least 12 or 13 years, 18 years plus, to basically learn how to function in society as an adult. And we also see hierarchies, dominance hierarchies typically happening, where societies are all based around this idea of pecking order. Who is the alpha male or female? Who are the sort of second in commands below that? And then how does everybody shape out from the top down? Such that if someone dies or a member leaves, all of those hierarchies need to be reestablished. And also we find that these hierarchies typically are set up amongst members of different families. So not everybody is always related in a vertebrate society. But the major thing that I'd like to point out is that when you're talking about social vertebrates, one major distinction from social invertebrates is that all members are autonomous. Basically, they could survive on their own if they wanted to. They are in a social situation because it's better for their survival because they've been taught to live in social situations. But if a prairie dog or a goose or a person wanted to pack up and live off the grid somewhere all by themselves, they could. It's not outside the realm of survivability. On the flip side, when we talk about invertebrate societies, we are not talking about a group of individuals who are all working together but are functionally autonomous and separate from one another. We're basically talking about a bunch of individual members that together act like one single organism. Basically, we have a situation where the division of labor is highly specialized. So basically, if you are in say, a bee colony, an ant colony, if you're a coral polyp, chances are you have one job to do, and you do that job very, very efficiently. Such that maybe you're a food gatherer, maybe you're a reproductive, maybe you're a hive cleaner, but you don't do any of those other jobs. And oftentimes you can be so specialized into that job that you're actually physically incapable of doing the other job. You cannot reproduce for yourself. Consequently, if you're separated from the colony, you will likely die. If you take a single ant and toss it off by itself, it will not be able to reproduce and establish a new colony. Same thing with bees, with these colony shrimp. That's what this guy is. That's a shrimp that lives inside a sponge. Coral. Basically, they're all related to one another. They're all one big family, and they need each other for even the most basic aspects of survival. So what we call this is the superorganism concept. So this is a long definition. Basically, the idea is that the superorganism is the reproductive or the social unit of eusocial animals. So, in cases of a superorganism, the idea is that the labor is so highly specialized that individuals are unable to survive by themselves for extended periods. So, functionally, the colony is the reproductive unit. Individual honeybees do not reproduce. Workers are sterile. Only the queen can reproduce. So functionally, the entire hive needs to reproduce in one big go to establish a new hive. You need to have a new queen produce. That queen needs to take a whole bunch of workers with her, and she needs a whole bunch of drones produced in order to fertilize herself. Without all three of those things happening at the same time, the honeybees are unable to spread and create a new population. All right. And beyond that, with superorganisms, we also see this, which is the tendency of individuals communicating with one another and interacting in very simple ways to produce very complex actions that are hard to explain. We call this emergent behavior. So basically the idea is that, if you look at bees have the ability that when they feel warm, they will arrange themselves at the entrance of the hives, and they'll fan their wings in such a way to promote flow from the bottom of the hive upwards into the top of the hive, pushing the hot air out. Now, no given bee is going around saying, hey, you guys, go down there and fan, you guys go up there and fan. They basically all just know that when it's hot, you go to the entrances and you fan. And this creates that nice ventilation. It's a simple behavior, but it creates a larger thing that actually looks very complicated. Same thing with ants. Ants are really dumb. Individual ants are stupid. More or less all individual insects are really stupid. They're not capable of critical thought. They basically just follow a few very simple directions in their head. But with that, if you think about it, ants basically know that if you have a piece of food, you tug on it. And you tug on it until the food is able to go back to the colony. If that piece of food is too big for you to carry, you don't know that. You just know you're supposed to tug on the food. Eventually, more ants will come and tug on it too, and you'll get this behavior where it looks like a whole bunch of ants are all working together to pull a big hunk of food along. But there's no plan in this. It just so happens that enough ants have all boinked into the same piece of food that you got a critical mass of them to scoot it along. So That's what we would call emergent behavior. Basically, what's the bumper sticker? Never underestimate the power of stupid people in very large numbers. It's kind of that idea, you know. Individually, bees, ants, termites, all of them are pretty stupid, but because they're all doing the same thing in very large numbers, they can create really incredible works like hives and termite mounds and ant rafts and things like that. All right, so if we're going to be ranking social societies, right? If we're going to look at, say, wolf packs versus people versus honeybees, honeybees are considered the highest level of known social arrangement. They are as social as you can get. And we call that Eusociality. Eusociality is only known in the insects. It's in ants, bumblebees, stingless bees, yellow jackets, hornets, paper wasps, and the termites. So our only non-hymenoPteran, or hymenoPteran, that's known to have Eusociality. Oh, I forgot. Naked mole rats. Weird, right? Who would have known? But they're eusocial. So what makes a society eusocial? Well, the first thing is cooperative care of young. So basically, there are a variety of adult organisms that all provide some care for the young. There is a reproductive division of labor, so a caste system, that depending on which caste you were born into, you will have different roles, and specifically, most people say it's eusocial if one of those castes is reproductive and all the other castes are sterile, so that they do not reproduce. And then lastly, there's the overlapping generations capable of caring for young. So the basic idea here is that you have multiple generations of adults that all overlap with one another, so that there's never a period of no care. So there's always some adult in there taking care of the young and prepping them for the future. Yeah. Some people, E.O. Wilson is kind of the guy who invented the idea of sociobiology, and he basically said that he thought that humans were eusocial, but as best I can tell, everyone pretty much agrees that we don't have an actual reproductive division of labor. Any human can reproduce. Maybe there are certain social situations where some people are less likely to reproduce, but we all have functioning equipment. It's not like honeybees where workers are actually sterile and can't reproduce even if they wanted to. So, that being said, there are lots of social interactions in insects that are not quite eusocial. Probably the most common of which we see is aggregations. So aggregations is basically just a group of individuals getting together basically for some cooperative action. Maybe they're building a nest. Maybe they are helping rear young with one another. But it's just sort of a random social interaction amongst a normally non-social insect in order to achieve a specific goal. Maybe they're trying to mate. Maybe they are getting ready for hibernation, like these guys are, right? Convergent lady beetles tend to hibernate together in large groups. Maybe they're trying to collect food, like these sawflies are. Regardless, it's a temporary sort of thing. It's not a truly social sort of species, long term. Sort of moving up, we see that there are some insects that we would consider subsocial, so being just below the social level. Subsocial insects are insects that provide parental care to their young. So, but they don't have any other social behavior. So basically they provide some level of parental care. Once those offspring are off on their own, no more social behavior for the rest of their life aside from safe mating. So, giant water bug is a nice example. These guys carry their eggs on their back. You can see right here. Sort of a step up from that would be insects that we consider communal. Communal insects live in a nest with other members of the same species, but they basically just all live together. It's like an apartment building. You all live in the same building, but you're not like going next door and helping the neighbor out with the cooking. You're not, birthing the baby or anything, unless you're like really good buddies with them, but generally you don't, right? So, but they're all just living together. Eastern tent caterpillars are a nice example of this. Are there tent caterpillars out here? I don't think there are western tent caterpillars. This might just be a purely eastern thing. If you go out to the east coast, you go into one of their deciduous forests, during certain years there'll be big outbreaks of these things. And basically it's a bunch of caterpillars that will build a huge silk nest on the branches of trees. And they all live inside of that, and they'll sort of crawl out of it and feed on the leaves and crawl back into the nest for protection. And some seasons they'll be really bad, and you'll just see trees that have like, you know, a couple dozen of these colonies all stuck up in them. It's kind of cool. And then we start getting into the things that are really starting to look like complex social societies. And these are what we would call parasocial insects. So a parasocial insect is any insect that exhibits one or two of the key eusocial traits. So basically they exhibit a little bit of social traits, but they don't go all the way to full eusociality. There's two major subdivisions in here. We have quasi-social insects. These are insects that live together. They share brood care, but every single member of the population is a functioning, reproductive. So this would be a little closer to sort of how humans live, right? Orchard bees, these guys right here, tend to be quasi-social. Basically, they all live together in a single hive. They all put their brood in the same place, and they all help take care of each other's brood, but it's a mixture of everybody's brood. So, it's like living with cousins, I guess. Semi-social insects, on the other hand, they share brood care, and there is a reproductive caste, but they don't have overlapping generations. So basically, in this situation, we see this in some leafcutter bees. You'll have a whole bunch of leafcutter bees living in a single place. There will be one queen bee that is reproductive. She lays all the eggs. There's a sterile female caste that takes care of the eggs and provisions them with food, but then they all die off before the offspring hatch. So basically, they set everything in motion, they die, and then when the offspring hatch, they go off and create their own hives in the future. Yeah. I already talked about Eusociality. Must have created that slide earlier. All right. Cool. So let's jump back into Eusociality. I guess just as a review, that's probably why I put it there. All right, just as a reminder, Eusociality differs from these things because the individual bees cannot start new colonies by themselves. Specifically, workers are sterile, so if you get a bunch of workers flying off, they can't create a new colony. And queens, when queens are being fed, let me rephrase that. In order for a queen to lay eggs, she needs to be provisioned with a lot of food. She needs to be provisioned with so much food that she basically becomes so large that she cannot fly by herself. Consequently, an egg-laying queen cannot survive on her own. She needs workers that provision her with food. And she can't migrate to a new location and start laying eggs, because in order to be light enough to establish a new hive and fly, she doesn't have enough energy to produce eggs. So it's kind of this real requirement that if you want to go create a new colony, you need queens and you need workers. So this creates basically some real restrictions on the life cycles that you can see in these things. So basically, this is the major division we see in Eusociality, is between annual and perennial eusocial insects. This is probably where I'm going to wrap up today, is after those. Annual life cycle. This is also called primitive Eusociality. This is basically the case where the entire hive builds up over the nectar flow, over the summer, and then during the winter period, the only one that survives is the mated queen. All the workers, all the brood, everything else dies off. So in this system, in the wintertime, you have a fertilized queen fly out and she seeks some place to shelter. So she goes and looks for, say, some loose bark on a tree. Maybe she digs a hole, or hides inside somebody's house. In the springtime, the queen flies out. She establishes a new nest. In that new nest, she lays a bunch of eggs. The brood is her first generation of workers. They come out and forage for the queen. Basically, they live like that over the entire spring and summer. The queen makes more eggs. The workers help her out. They go foraging, all of that. In the fall time, then, the queen lays a whole bunch of unfertilized eggs that will become the male. Those drones. And then her last female brood will all emerge as queens that are no longer sterile. The drones in the new generation of queens will all mate. Those new queens will go out and find a place to hide for the winter time. Everybody else stays in the hive and they die during the winter period. So, functionally, that's just sort of the cycle. Only mated queens survive, everybody else dies. And this is what we see with bumblebees, the yellow jackets, the paper wasps, all of that. That's why if you have like a paper wasp nest hanging out during the summertime, you know, an easy way to get rid of it if it's not a pressing concern is just to wait for the winter and then knock it down, because they're all going to be dead. And that's just a visual there. Let's jump to the eusocial current, and then that's where we'll end. So then there's perennial life cycles, which is basically what we see in honeybees, where eusocial societies last year-round. And the big thing here is that in a perennial eusocial society, the workers are maintained all year. So basically, they need to provision enough food so that during the worst periods of food gathering, they can keep workers around. Generally, these populations are characterized by declining population during the late summer, fall, and winter, followed by rapid buildups during nectar flows or resource flows. And these populations also have the ability to produce males and new queens depending on resource availability. So they're not tied into this idea that we produce males at the end of the fall. They basically say, we have a lot of resources where we seem to be on the cusp of outgrowing this hive. Let's produce some males and some new queens so that we can split off and create new hives. That's the basic idea. And this is what we see in Apis, the ants, and the stingless bees. Those are the major ones that have this sort of life cycle. All right, so we'll cover swarming and the beehive life cycle on Tuesday.